Hi there, welcome back to this channel. In this video, I'll quickly teach you how to name hydrocarbons. Now you see, I've written a set of rules here that will cover for both alkane, alkynes, and carboxylic, the aldehydes and ketones. But these rules will not work for carboxylic acid families and the esters, alkanoids, and proteins. So this rule is just for um, alkynes, and the aldehyde and ketones. Or in cases where you just have carboxylic acid as one carboxylic acid as a functional group, that is monocarboxylic acid. So this principle can also work. These rules can also work. All right, let's get on to it. So the first principle says, so I'm going to be naming this four quickly. The first one says we should identify the longest carbon-to-carbon chain, and that is the parent chain. The parent chain is the longest carbon-to-carbon chain in the molecule. So identify that longest carbon-to-carbon chain. Now, this word identify makes sense because sometimes the longest carbon-to-carbon chain is usually not given directly in your questions. It's usually hidden in a way. Is that okay? So you must know how to identify it. So you must try to, as much as possible, to identify. Sometimes you might not be given a straight chain like this. You might be given a kink. Kink means a bend. Is that okay? So you might be given a kinked molecule that is kinked severally, and you'll be expected to find the longest carbon-to-carbon chain. So we're going to be looking together how to decipher, to find the longest carbon-to-carbon chain here. It says in the given structure, so we should number in two directions, number leftward and rightward. So we're going to number leftward and rightward. So there's no front or back yet. In the molecule, we are going to decipher the front and back depending on our numbering. Is that okay? So we're going to start with this one. So we have to identify the longest carbon-carbon chain. Now, if we start from this, and we number here, we'll go 1, 2, 3, 4, 5, 6. We have 6 carbons. Let's see if we go this way, there's another carbon here. So let's see if we go this way. 1, 2, 3, 4, 5, 6. Okay, that's still 6. So whether we go this way or we go this way, we're still going to have 6. But now there's another carbon here. How about we go like this? If we go this way, 1, 2, 3, 4, 5, 6, 7. So with this, starting from here, we're going to have the longest carbon-to-carbon chain. Now, listen, you cannot, some people usually digress and come back. They will do something like this. 1, 2, 3, 4, 5, 6, 7, 8. No. This is not connected to this in any way. The only link between this, the only link to this is this carbon. And this carbon is connected to this guy and this guy separately. So one carbon must be connected to one carbon. In your molecule, in your longest chain, in your parent chain, one carbon must be connected to what? To one carbon. As far as that carbon must stay in the parent chain. If that carbon is a part of the parent chain or the main chain, it must be connected to only one carbon. If it is not connected to only one carbon, if there's one carbon that is connected to 2 other carbons, and those 2 other carbons are in the main chain, then you have numbered wrongly, or you've identified the longest chain wrongly. So here we said going like this is the longest carbon-to-carbon chain. So we have 1, 2, 3, 4, 5, 6, 7. All right, with 7, having identified that the longest chain is 7, we have hept. So you see what I did? Having identified that it was 7 carbons, I wrote hept there, knowing that it's going to give me, we are going to have hept as the, like the surname, kind of. So with 7 carbons. Now the next thing we're supposed to do is to identify substituents if attached. And functional groups. Now, for your exam, you're going to have substituents attached. So, and then the functional groups with their positions. So now, this is very important. Identify substituents and functional groups with their what? Positions, according to your numbering. Now, this case is with when the functional group is not a part of the chain. And so, but if the functional group is a part of the chain, then you have to number in a way that will give the functional group the lowest possible number. But first, let's identify the substituents. Now, substituent is a substituent is any other atom apart from carbon and apart from hydrogen that is attached to the main chain. Let me repeat that. I said a substituent is any other substance apart from hydrogen, any other atom rather, apart from hydrogen that is attached to the molecule. So let's go on. Now, seeing all of this, we see that this hydrogen is hydrogen. So any substance such as Cl and Cl that is not in the main chain, that's attached to the carbon in the main chain, is going to be a substituent. So here, also, even though this is CH3, which is hydrocarbon, alkyl group anyways. That's not hydrocarbon. Alkyl group. We can say that is a substituent. Why? Because it's not a part of the main chain. So if you're not a part of the main chain, you are going to be a substituent. That's the rule. So all of these H's are not substituents. Right. Now, and the functional group here is single bond. So it's an alkane. Is that okay? So in fact, we can already even go to say that what? It is what? Heptane. It's going to end with heptane. So heptane is like the surname. Is that okay? So the next one says we should use the numbering that gives the functional group of substituents the lowest possible number. So if your functional group is a part of the chain, that is in that sequence of your longest chain, if your functional group is there, then you should number in such a way as to give the functional group first the lowest possible number. And if there is if your functional group is not a part of the chain, you have only substituent there, then you should number in such a way as to give the substituent the lowest possible number. All right, for this case where we have single bonds all through, then we have heptane. So we'll number in such a direction that will give this substituent the lowest possible number. Now let's start by numbering from here. We start 1, 2, 3, 4, 5, 6, 7. So now this is the first direction. With this direction, these are fronts, these are like this the back, this the front. Either way, there's no front or back. Just take it as this direction we are going, this first number. In the other number, we're gonna have the reverse. 1, 2, 3, 4, 5, 6, and 7. Is that okay? So what we'll now do is this. Let us see which numbering has given our substituents, which numbering has given them the lowest possible number. When we went like this, we had 1, 2, 3, 4, 5. So the first substituent appeared on 5 and 5. So we have 5, 5. Now we're writing both 5s. We're writing 2 5s. You must write the number of, you must write the numbers that the carbon number that the substances are attached. If there are more than one substance attached, write that number in the repeated number of times that substances are attached. Is that okay? Provided they are the same substance. So this is chlorine and chlorine. So we have 5, 5. Is that okay? Then the next substance is attached on 6. 5, 5, 6. Now when you add this together, you're going to have 16. So and that is quite high. Let's see if we go like this. We're going to have a lower number. When we go like this, the first substance appears on 2. 2, the second substance appears on 3, 3. So, and vividly, we can say that this is the lowest numbering system. So we are going to go in that direction. Is that okay? Because we got the lowest possible number for the numbering in this direction, we are going to go in this direction. So then, what is our name? What is the name of this molecule? So at 2, what do we have? We have 2-methyl. And what do we have on 3, 3? We had 3 chlorine. So it says we should use di, tri, tetra, penta, etc. according to the frequency of occurrence of a substituent. So seeing that chlorine appeared twice, it's going to be 3, 3 dichloro. Now, it says we should use also between numbers and numbers, put commas. So separate numbers with commas and separate number and letter with what? Dash. So you see here that I'm using a dash here and I'm separating here with what? A comma. Dichloro. Now this is, we are done with the naming, but now there's one more thing that you should do. You should arrange with respect to alphabetical ordering. So alphabetical ordering is also necessary here. So what we do is check the first letter. The first letter here is a D, and the second letter, the first letter here is an N. So which one comes first? This comes first. So the name of the molecule will therefore be 3, 3, dichloro. So this shows that di means that whatever you write here as a prefix must be how many numbers you have here. Is that okay? All right. So dichloro, 2-methyl, 2. So you put between number and letter, you put dash, 2-methyl, 2-methyl heptane. So notice, just write it together. You don't have to put a space in between them. Don't put a space between this. Just write it together. So the name of this molecule is 3,3-dichloro-2-methyl heptane. All right. Now I know that you might not get that so clearly. So what I'm going to do is I'll also explain this one in detail. Then I'll leave a set of questions that you're going to attempt on your own after the end of this. By the end of this video. So the next one says we are going to adopt the same rule. So let's identify the longest carbon-to-carbon chain. Now, looking at this molecule, I know that the longest carbon, if we count like this 1, 2, 3, 4, 5, 6, 7, we're going to have 7. What if there is a C2H5 here? If we go like this, we still have 7 because it's CH3, CH3. Now, if we go like this, now if you look at this, there's also a CH3 here. So we can count 1, 2, 3, 4, 5, 6, 7, 8. Is that okay? So the longest carbon-to-carbon chain here is this. All right. So we can now number in the directions we want. But before we number, let's identify our substituent. Substituent is any guy that is not H, that is not in the parent chain. So we have this guy is a substituent, this guy is a substituent, CH3 is also a substituent. All right, we have 3 substituents just like we had in the other one. Now, what are the positions? Now, looking at this chain, you don't have to begin to number in the 2 directions again. Do you know why? Because if you look at it well, you see that most of the molecules are tilted towards this side, isn't it? So because of that, this direction will give us the lowest possible number. But now, you have to take note of the fact that there is a double bond here. So we have to number in such a way as will give, in such a direction as will give the functional group, not the substituent now, the lowest possible number. The functional group, there is order of priority in organic compounds. Functional group have a higher hierarchy. I mean, is in the higher hierarchy than the substituent. So it takes priority over the substituents attached. So there is a functional group here. So because we are supposed to number from this direction, but because of this functional group, because if we number from this direction, this functional group will fall on 1, 2, 3, 4, 5. And notice how I counted. 1, 2, 3, 4, 5. So it's going to fall on carbon 5, that bond there. If you go from here, 1, 2, 3, it's going to fall. The bond is in front of 3, so it's going to fall on 3. So we number in this direction. Is that okay? So 1, 2, 3. So this double bond appears only once. So and it's on carbon 3. So and it's on carbon 3. So we're going to name in this direction. In this direction. All right, so how many carbons do we have here? 1, 2, 3, 4, 5, 6, 7, 8. So 8, right? So go to write ox. 8 is for ox, right? So, ox is for 8 rather. So we have oct. What carbon is that? Carbon 3. Oct 3 in. Is that okay? So that's going to be the surname. All right, how about the substituent that will be in front? Now this is 1, 2, 3. Now notice this substituent and this substituent are the same, right? So, and they are on the same carbon from here, 3, 4, 5, 6. So this will be 6, 6 dimethyl or dimethyl. And here we have bromo on 4. That will be 4 bromo. Now, you now ask yourself, which of these will come first? Bromo, of course. So we go on to writing the name as 4 bromo. We have 4 bromo. 6, 6 dimethyl oct 3 in. Now, in other textbooks, you might see that this number is usually put before the surname, so to say, the parent's name is the same. So if you want to do that, you could just say dimethyl 3 octene. Is that okay? Or that is another way to go about it. All right. Now we are going to go to the next one quickly. So the longest carbon-carbon chain is quite vivid here. I think it's this long chain here. So let's count how many carbons we have there. 1, 2, 3, 4, 5, 6, 7. Now here, also, you see that the functional group is OH here. So it's going to take priority. It's going to determine where we're going to count from. So, and the best direction that will give it the lowest possible number is this direction. So what do? We count from here. We count from here, from this direction. So we are going to have 1, 2, 3. all. OH is all, isn't it? And then the remaining guys will be the substituents. So we have chlorine appearing twice. So this is going to be, chlorine is on, so if you count from here, 1, 2, 3, 4, 5, 6, 6. Is that okay? Because there are 3 chlorines. So 5, 6, 6, tri chloro. Do you get that? Trichloro, because there are 3 chlorine there. Trichloro, we have 1, 2, 3, 4, 5, 6, 7. 7 carbons, that will be hept. Now, this is on carbon 3. OH is on carbon 3, so that will be hept. Now, I'm going to put this here because of the space. Or let me just write this in. This becomes 5, 6, 6 trichloro hept. Now, look at this. Now, because it's single bonds all through, it becomes heptane. Heptane. The OH is on carbon 3. 3 all. Is that okay? Or you want to go the other convention that says put the number before it. So it becomes trichloro. When you write the chloro, it becomes chloro 3-heptanol. Is that okay? Now, the reason why this is sacrosanct is because you can change, this can change to enol depending on whether or not there is unsaturation there. So if there's an unsaturated, if it's an unsaturated alcohol, it becomes hept, maybe the double one is on 3 also, hept 3N. Now, okay, I'm going to cite an example like that. Let's continue to the last one here. So with this, you know, there's double unsaturation here. The greater unsaturation, this and this other unsaturation. So in this case, the priority will be on the triple bond. So triple bond has a higher priority than the double bond, and double bond over the single bond. So we're going to go in this direction because obviously it gives you the lowest possible number. So, and it means that these guys are only substituents, and it's going to be on the last carbon. Is that okay? This does not take priority. You won't say the God probably will be there. You should number from here. Your priority is the triple bond here now. So we go like this. 1, 2, 3, 4, 5, 6. We have 6 carbon. That is hex, isn't it? And bromine is on 6. So we have 6 bromo. Is that okay? Hex. Now, there will be no dash there. 6 bromo. Hex. Now, your double one first, because the last one is the family now, the surname, sort of. So which is the parent name. So the parent name here is Yne. Is that okay? Or YNE. So, and in is also there. Is that okay? So in is on carbon 3, so we have X 3 and triple bond is on carbon 1. X3 and 9. Is that okay? Now, in some textbooks you might see that 1 is put here, that is X3 and 1 ion. Whether you put 1 here or not, you are correct, because ion there, by putting just ion there, shows that that triple bond is on carbon 1. Is that okay? It cannot be mistaken. All right. So that is the name of that carbon. Now, I was talking about something here. What if we were given a molecule that was like this? We have something like this, for example. Okay, let's even put 2 double bonds, for example. Let's put 2 double bonds. Here. Maybe they should follow. Let's put them to follow each other. So we now have something like this. We now have this. OH. Is that okay? Let's say this OH was here, for example. Okay, yes, let's say we have this kind of molecule. Let's say we have this kind of molecule. So what if we are asked to name something like this? How would you go about it? It's very simple still, regardless of how cumbersome the molecule might be. Now look at this. What you are going to do is, as it is this way, you are going to count the rule still applies, identify the longest carbon chain with this because I just made it up this way. So I made this the longest carbon chain. So now we're going to identify other structures that are substituents. So there is no substituents here, we only have functional groups. So, and there are two functional groups here. We have the double bond, the unsaturation, and the OH. Is that okay? So we are going to go on to numbering in the direction that will give them their lowest possible number. And as you can see, the direction is this direction, okay? So what do we do here? How many carbons have we here? 1, 2, 3, 4, 5. 5 carbons. That's pent, isn't it? So this is pent now. If there was, let's say there was a substituent here, for example, I just don't want to leave out the substituent. Let's say there was chlorine here. This becomes 1, 2, 3, 4. This is 4 chloro. It is possible that you don't have a substituent. Don't get me wrong, it's more possible, but I don't want to leave out the place of substituent. So I have pent, as I said. Pent, what is this now? This is pent. Now, the double bond comes first. Is that okay? Is that okay? So you have, the double bond comes first. So we have 1, 2. The double bond is on carbon 1 and carbon 2. Is that okay? Pent 1, 2, N. Is that okay? That shows that the N, that is N, shows us that is a double bond, isn't it? It is an alkene, is that okay? So we have 1, 2, N. Now, all, which is the master functional group there, OH is on what? Is on carbon 1 and carbon 3. So we have N1, 3, diol. Now, this is why this convention is better, because in this convention, we cannot bring these numbers forward here. Is that okay? So we have 4 chloro, pent, 1, 2, and 1, 3, diol. All right. So that is it for this video. As a work to do, you guys should put these answers in the comment section. The answers to these molecules I'm going to be drawing here. So do them as, just to let me know that you have understood what I explained here so far. All right, so provide the answers to these 2 questions in the comment section, and I will see if you are correct, and see you in the next video. God bless you. Make sure to share this content with some of your friends that you know might need it. And please subscribe to the channel. I notice some of you are not subscribing to the channel. Just click that subscribe button and the bell notification to be notified if I drop any insightful content like this. God bless you.